variation of conductivity and molar conductivity with concentration. Done? So how it vary? Tell me. What is conductivity? So conductivity is directly proportional to ions carrier. Yes or no? If you increase the ions, then conductivity will increase. So tell me, so as we know that conductivity, that is a specific conductivity K, it is directly proportional to ions per unit volume. Molar conductivity depends on how you define conductivity. K is conductivity of 1 centimeter cube. A specific conductivity is conductivity of 1 centimeter cube solution. And if number of ions will increase in per centimeter cube, conductivity will increase. Therefore, conductivity is directly proportional to ions per unit volume, not only ions, per unit volume. And when dilution occurs, it means you increasing the volume, making the ions same. So what about K? K will increase or decrease? Decrease. Therefore, with dilution, K will decrease. K will decrease with dilution. Why? Because on dilution, ions per unit volume will decrease. Yes or no? And with dilution means you can say K will decrease on decreasing the concentration. If you decrease the concentration, or you can say on increasing the volume. So if you increase the volume, concentration will decrease and K will also decrease. Got it? So write down. So conductivity will always decrease with decrease in concentration for both a strong and weak electrolyte. That is on dilution. Got it? Now, what about molar conductivity? What about molar conductivity? Molar conductivity, lambda or equivalent conductivity will be a specific conductivity into volume. Yes or no? And on dilution, moles is constant, you increasing volume. So on dilution, we will increase, K will decrease. Yes or no? But rate of increase of volume is greater than rate of decrease of K. Therefore, on dilution, lambda m will increase. So the rate of decrease in K will be less than compared to increase of volume. Therefore, the molar conductivity will always increase with decrease in concentration or increase in volume. So what is the relation here? Lambda m will increase with decrease in concentration, that is increase in volume. So you have to write this. So on increasing the volume, concentration of C will decrease and lambda m will increase. For strong electrolyte, one equation is given, lambda will be lambda naught molar, this is the molar. Molar conductivity will be equal to lambda naught minus A C raised to 1 by 2. That is, tell me, at infinite dilution, infinite means C becomes 0, lambda will be lambda naught. So what is this? This is conductivity at any volume, molar conductivity. Molar conductivity at any volume, while this is at infinite dilution. This is a molar conductivity at infinite dilution. And what is the A? A is constant. A is constant, which depends on charge on anion or cation, which depends on charge of anion or cation of electrolyte. So A is constant and depends on charge on anion or cation for given solvent. If solvent is different, then A will also different. For same type of electrolyte, A will be same. It means that for NaBr, NaCl, both have same A, because both have same charge. It has also +1, it has also -1. So this is called same type of. So how you calculate molar conductivity of weak electrolyte? So you know that what happened in a strong electrolyte. So a strong electrolytes, you know, the conductivity depends on carrier, depends on ions. And for a strong electrolyte, for example NaCl, when it dissolve in water, it will dissociate 100%, and the carrier will be Na plus and Cl minus. So with dilution, carrier will not increase. Yes or no? Carrier will not increase. But with dilution, that is decreasing the concentration, molar conductivity increases. Why? Because the force of attraction between Na plus and Cl minus will decrease. Yes or no? But in weak electrolytes, when you add more water, that is on dilution, degree of dissociation increases. Yes or no? And when degree of dissociation increases at infinite dilution, degree of dissociation becomes 1, that is act as a strong electrolyte, and number of ions will increase. So in weak electrolyte, number of ions will increase with dilution, and if number of ions will increase, it means carrier will increase. If carrier will increase, it means conductivity will increase. Yes or no? And so this is the difference between a strong and weak electrolyte. In a strong electrolyte, only the force of interaction will be decreases, while in weak electrolytes, number of carriers will increase. Therefore, the curve for the weak electrolyte, if you draw the curve of molar conductivity for weak electrolytes versus concentration raised to 1/2, curve will be like this. Curve will be like this. Yes, for weak electrolytes, curve will be like this. It states that when concentration decreases, if you go towards this, when concentration decreases, it means when you increasing volume, conductivity is decrease, not decrease, increase. See here, conductivity will increase. At infinite dilution, when tending to 0, there is a sharp change in conductivity. Yes or no? Why? Because at infinite dilution, it becomes as a strong electrolyte. All ions will dissociate. Take the example acetic acid, CH3COH. It will dissociate in two parts, CH3CO minus and H plus. But when at infinite dilution. therefore carrier will increase. If alpha increases, it means number of ions will increases. Yes or no? So as concentration decreases, alpha increases, that is ions increases, and hence carrier increases, therefore conductivity increases. But what about the strong electrolytes? Curve is like this. There is no sharp change. As concentration decreases, molar conductivity increase, but not like weak electrolyte. Why? Because it has simply the force between cation and anion will decrease because of dilution. The distance between cation and anion will increase. Yes or no? So therefore there is no sharp change here, but it has sharp change. Clear? You can calculate this value. This is called lambda naught. That is maximum conductivity of a strong electrolyte. But you can't calculate the maximum conductivity of weak electrolyte. Yes or no? From this curve you can't calculate the maximum conductivity of weak electrolyte. That is called the limiting conductivity. Therefore one law is required, that is called Kohlrausch's law. This curve for weak electrolyte, and this is for a strong electrolyte. Yes or no?